All right, well, great. Welcome everybody today to the April 2023 ROS Industrial Developers Meeting. We'll hop to it. I don't think I have to manually let people in, so that's kind of a plus. This is not the full agenda. We have a couple different guest speakers who will share some updates. I just didn't get it on this particular slide. This is just what I'm going to briefly share before turning it over to our esteemed colleagues. We have not listed here on the agenda an update on using OPC-UA with ROS based systems, Tesseract ROS-II update and activities, and some news on training. We've recently made some overhauls and improvements to training. So Lily Bay Wallace here is here to share that with us. And then we'll have time for open discussion. All right, with that being said, we can get the ball rolling. So one of the first things I wanted to share for those that are engaged with the consortium or have been checking out or take advantage of consortium resources. The week of the 22nd in May is Automate, which is the largest America's robotics and industrial conference. So that is being held the 22nd through the 25th. And on the 25th, that same Thursday, so we're going to have some presentations. There'll be an update from all your regions that support the ROS Industrial Open Source Project, and a number of other contributors and collaborators sharing kind of what they're working on. The night before, we'll have a welcome dinner. And hey, this is the 10th time we're getting together. I'm including the link for reference, so feel free to check that out. In July, the 18th through 20th, we'll be hosting here in San Antonio a ROS Industrial Training. Yes, with a special topic on building a motion planning pipeline. That registration is open. And so we look forward to hosting folks down here. It actually, I believe, is about half full already, right? So people are jumping on the registration bandwagon early. So anyways, feel free to check that out. I've included the link for your reference. Let's double check. Thanks. So check that out for your reference, right? So if you're interested in getting involved in training, obviously Lily is going to be presenting an update there. All those resources are online, available open source as well. Reach and ROS-II, so very excited. Some of our collaboration partners over at Ohio State CDME have agreed to kind of like allow us to kind of work on getting Reach over to ROS-II. So for those who aren't familiar, Reach is a utility that kind of like enables you to assess waypoints that you've applied to a mesh, you know, and assess the reachability for a given manipulator position. So there's an example on the right there. There's the Reach repository. Hopefully, actually, maybe it won't even be early fall. Maybe it could be a little sooner, but we're ironing out that workflow and those details as I present this. So stay tuned. Another exciting little tidbit of news is for those who are familiar with robotic blending over the years. We're excited to say we've got another round of robotic blending going, milestone 5. Just kicked off March 28th. So we will be hosting a couple different integration events. The cool thing is we're going to be taking the prior repo, which is this here Godel that's referenced, in pulling all the goodness from Godel, modernizing that whole scan and plan implementation, merging with the scan and plan workshop, to create something basically more contemporary and new in ROS-II, and ideally we'll have a couple replications left behind. So a number of our different collaboration partners will have kind of the latest and greatest in how to execute scan and plan processes based on this. Shout out to Steel Founders Society of America. They're the champions and primary funders of this initiative. But we have a number of different both members and universities and in-kind collaboration partners involved. So pretty exciting. Happy to see that, and the benefits to the overall a number of different repositories in the ROS industrial ecosystem. So we're pretty excited to see that. So that's kind of the latest relative to kind of like collaborative developments and some different events and activities coming on. With that being said, I can pass the mic, if you will, to Doug Smith. Doug, are you ready to go?
Yeah, I'm ready.
All right. Do you need to share, or?
I do need to share, yeah.
I can stop sharing. You should just be able to hit share. So Doug Smith is like a senior research engineer here, supports a number of the different ROS industrial activities that we do here. A lot of experience with industrial hardware, PLCs, and industrial automation systems. And here we go. He's going to talk a little bit about OPC UA and PLCs for industrial control. Thanks, Doug.
So this is something I worked on a couple of years ago, involving using a PLC as a bridge to different industrial devices and communicating with that via OPC UA. So a common challenge in applications is you need to control some type of device or some type of I/O module. A lot of the times it'll only be available with an industrial field bus with no basic TCP/IP interface available. For example, a push core spindle, their force control device has a simple TCP/IP interface. It's got several of them, but the spindle has no other option other than an Ethernet IP. So your project is usually not to implement a field bus protocol. Getting bits and bytes flying back and forth isn't, your goal. It's not the end goal. It's not going to make your customer happy. And anytime you really spend on basic communication, getting bytes flying is just blocking your active work. A common problem, there's too many of them. They've all got some similarities, but they're very different in a lot of ways. Ethernet IP being big in Allen Bradley and Rockwell Land, EtherCAT being bigger in Europe, and Profinet as well. A lot of the time, the open source libraries are lacking. And even if they're not lacking, you still need to be real familiar with the protocol. You're going to have to dedicate time to learning a PDO from an SDO, from a SIP data tag exchange to cyclic communications, directed messages. And nobody has time for that. If you're doing project work, it's probably hourly. What are you going to charge the time to learn all the nuances of a industrial communication protocol? Why use PLCs? These networks are all made by PLC manufacturers. They're designed to be used with PLCs. They're going to be way more flexible on a device like an AnyBus. And so one way you can connect to things is a device called an AnyBus, but then you need a specific hardware device for a specific protocol to another specific protocol. When you use a PLC, they're going to have different modules and libraries and add-ons available, and you'll be able to access different networks in exactly the same way. It's also nice to implement your logic and control in the PLC. For something like a spindle, you're probably going to have to check a couple of flags every time the thing turns on, monitor it for safety, make sure that a certain sequence is followed whenever you turn the thing on. But from your application code, all you want to do is turn the thing on. It's a lot easier to do this in a PLC. You're not going to have to worry about somebody hitting Control-C or ROS core breaking. So why OPC UA? You can't really run ROS in ladder logic or structured text on a PLC. There's some newer developments, but your application code where you're doing your vision and 3D processing and motion planning is probably on a PC. So you need some way to communicate with that PLC. It's super easy to use. The libraries for it are very nice, and even Rockwell supports it now. They were the big holdout for several years, but even they have support for OPC UA. It's no longer a new package I'm working on. It's a few years old now, but I had worked on a ROS package to automatically map data and create services. All you'd have to do is create a special structure that follows a specific format on the PLC and give it both the ROS code and the PLC the name, what you want to refer to it as, and it would automatically create different services and publishers for you. So getting set up, you create and map your I/O the same way you normally would. You'd have to refer to your PLC's manufacturer specifications. I don't want to spend too much time on this, but I'm just mapping some bits and bytes going back and forth. You have to create some structures to actually map the bits and bytes in your PLC software. You write your PLC code like normal. Here's a simple block to control a push carb spindle. You can see there's a few extra things: checking for drive errors, fault resets. Those are all flags that have to get set whenever the spindle powers on. Then you define your OPC UA mapping. You basically just create another structure using a format similar to what you see on the left. You've got a structure named status, a structure named input, and a structure named output. You can have multiple level structures under input and output, doesn't matter. But it will automatically make anything that is input a writable via a service. You call your function block on your PLC like normal with those exposed values. So that function block FP spindle was what you saw before. You don't have to write it specifically for ROS or for OPC UA. You just write a standard function block with inputs and outputs. As mentioned, the services and topics would be created automatically. It's still ROS-I at the moment. Performance with a modern PLC like Beckhoff, reading and writing is extremely fast. Actually writing and getting a response is between 2 to 3 milliseconds. Manually reading takes 2 to 3 milliseconds as well. One thing you run into with every PLC manufacturer, they limit the rate that OPC UA will publish. So the automatic publishing of topics will be limited to something like 50 milliseconds, but you can always pull it directly if you need something faster than that. So this was a very simple little test output I had setup I had here, the simple PLC code. I've got a digital out value that I write to, and it's connected directly to a digital input. So there was just a little bit of Python code. It's not super important, but it's just showing that by calling the service, calling the service on the right, I write to that output, and I can read the new value from an input. This was just a very small performance test showing the amount of time it takes to write to that output, read from the input with the new signal. So the input module I had has a 3 millisecond debounce time. So it takes me approximately 2 milliseconds to write via OPC UA, telling the digital output to turn on. I immediately start pulling the digital input value, which is connected to that digital output, and it takes 5 milliseconds until I'm actually reading a true high value. And you've got that 3 millisecond debounce time, adding 3 milliseconds to that, so performance is very fast. And that's there. This is available on GitHub, both the a Beckhoff TwinCat 3 project and some old ROS-I code. And that's all I've got.
Thanks, Doug. What about do you have the links for the GitHub repos? If you drop them in the chat.
Yeah, I can put them in chat.
Perfect. And then that way I can add them to the archive. Great. And then if you get a chance, just I can combine whatever you're comfortable sharing with your deck. I can combine in the one deck. So thanks.
This presentation was also on GitHub.
Perfect. Not messing around. All right. Thanks, Doug Smith. Any questions for Doug before we move to our next topic?
Hi, Doug. Dennis here from Germany. I have a question. Which library are you using? Are you using free OPC UA or Python free OPC UA or?
The one I'm using is Async UA. I think it's the same. It's Async UA. It is made by free OPC UA.
Yeah. Okay. No. Yeah. This async version is a newer one. Yeah. Okay. Cool. I guess that you probably started, as you mentioned, one old package, probably ROS OPC UA communication, maybe.
I did, but it's extremely limited. You have to write a bunch of, you have to create all of that stuff manually. The nice thing about this is you can have a big complicated struct with multiple levels of inputs and outputs, and you don't have to update your Python code. You can just make changes to your PLC like normal, restart the ROS node, and it'll automatically map all of that.
Okay, cool. And have you managed to map all the, I know back then we had an issue in mapping some of the OPC UA data types to ROS basic data types. Are you basic or how are you mapping individual fields from the objects? Because when I have OPC UA objects, I have some methods inside, I have some variables inside. Variables can be topics or something. The methods would be services typically. How are you approximately doing this?
I'm probably doing anything that isn't an int, float, or a bool as a string.
Okay, so you are putting everything inside string. Okay, cool.
It does create individual topics and publishers and subscribers for each thing underneath that.
Okay, okay, I understand. So just to clarify, so you are creating individual topics for what's called for individual objects, so to say, in OPC UA, but then you set individual fields. You set using strings or something, so you provide JSON inside string or something like that.
Let me start a screen share again, and I can show you.
I would like to see some object example if possible, if you have time. Sorry.
See. I think that's the right screen. So I'd have to dig more into the code to. I've got it here.
Okay. No, but if you maybe you don't have to show me the code, but if you open the OPC UA viewer,
I don't have it actually running at the moment. I'm stuck in Windows at the moment.
Okay, no problem. But do you have
Sorry.
somewhere here OPC UA object? No. Okay, no problem. No, I'm just interested in how you map the individual objects and how you send complex objects to OPC UA server.
So I basically have a recursive lookup on how I'm actually mapping the data.
Mm-hmm.
For each child.
Okay, I see.
Multiple layers
And then you create topic for each of them, or?
Right. So if I have a complex struct with multiple levels of stuff, let me try and find a good one here. Like the forest control unit. Don't have multiple levels there. So here's something with multiple levels of a structure. So this is just a basic test structure. I've got my status, my input and output. If I look at my output here, I've got just a couple of booleans, a digital, or not digital, a dint, and then another substructure here with just another number just inside of that structure. And it's able to parse that and then parse the children of that and get the actual data type of it. So instead of trying to map one big struct, which works with Beckhoff, but does not work with other PLCs like Kiba.
Okay.
Beckhoff can just straight up create an object for you, and the Python code will make a Python object for you, and you can publish that whole thing all at the same time. This custom data structure. That's not true of all PLC vendors. So I don't have all PLC vendors. I was at least going to try and make it work on the two that I had. So I took the lowest common denominator approach of mapping each element individually.
Okay, and you, for each element individually, you create a topic or something.
Right, yes.
Okay, okay, no, good, now it's all clear, yeah. Okay, thank you.
Yeah.
Thanks, Dennis, thanks, Doug. All right, so up next, I've got Tyler Marr on deck. Tyler, are you still online?
Yep, I'm here.
Perfect, I know you're juggling some things, so I appreciate it. Do you need to share, or are you just gonna speak?
Yeah, I'm going to share something.
All right, cool. Thanks. Tyler's going to talk to us a little bit about ROS-I Tesseract updates.
Awesome. You should be seeing my screen now. Okay. So yeah, Tesseract ROS-I was has long fallen behind. I think we originally did this, we set it up for ROS-I whenever we were working on a project that we were running on dashing. And it did not get any updates since then until now. And so now at this point, Tesseract ROS-I is up to par with Tesseract ROS. It's running all the latest versions of Tesseract. And so, yeah, so we can use Tesseract in ROS-I now as reliably as you can use it in ROS-I. I've done some work on this, and then also shout out to GitHub users, Arjuman and Afrix. They helped a lot in this contribution of getting this up to speed. So thank you to them. And then a quick demo of this. So for those unfamiliar with all the new Tesseract Qt stuff, this is what the widget looks like. So just an RViz panel, basically. You have your environment, trajectory viewer, manipulation viewer. There's an empty planning tab right now. I guess it's future plans that Levi has, but just kind of things you'd expect. You can kind of look at the different panels, or the different scene state. There's a whole bunch of different stuff. Basically, any parameter that you would have in Tesseract. So there's like an allowed collision matrix viewer. There's viewers for that. You can see the group manipulators, baselink tip. And then one of the cool things you can do is actually do a contact check. So you can use the Tesseract contact checker live, and then you can see all the contact results. So I can see like between the HC10 and the UR3, and you click on it, it actually shows you the contact. And if you look through this, it'll actually, drag this out, it'll actually tell you how far apart they are. This can be super useful for debugging various things. I was just using this for debugging some of my allowed collision stuff. But anyway, yeah, and then you can look at the collision objects like you would expect, all of the bounding boxes of things, and then all of the frames. This is all just in Tesseract. It's not using like the TF frames or anything like that. And then, another really cool feature is the trajectory viewer. So you can store up a bunch of trajectories, and then actually, whoops, I gotta turn this on. So I'll hide the previous environment, and then you can visualize and watch the trajectory move around. In this case, we see the HC10 planning around the UR right there. And then a nice handy thing that you can do is you can go in and actually go to each individual state, and then look at the state, look at all the joint positions, joint names, positions, velocities, timestamp. And then you can actually also view a plot of it. So you can see the position plotted over time, velocity over time, acceleration over time. And then you can save actually these trajectories and then load in other trajectories. So in theory, what you can do is you can have this Tesseract environment pulled up as long as you know, I think you have to know about the URDF, but you could load in a trajectory from somewhere else. So I could save off this trajectory and send it to somebody else working on this project, and then they can load up and then see the trajectory and actually step through it all the same. Right now, those files are pretty big because they contain like all of the history of the Tesseract, all the Tesseract environment history, and it's all just serialized. So they can be pretty big files, but they're pretty handy. And then there's also this manipulation widget, which you can use to move it around. You can move the different robots around. You can move them in Cartesian or joint mode, specify which manipulator group you want to use, specify your working frame. So right here, in this instance, I specified the working frame as the UR3 TCP, which is right in the center here, and my TCP frame as the HC10 TCP, which is also right in the center. And I just basically set the position to be exactly on top of it with a rotation around it. But I could make this working frame anything, make it the table, and then change the Z value to be 0.2, and it shows you the IK solution, which can be helpful debugging things. But yeah, in general, that's the Tesseract widget for those unfamiliar. And yeah, this is all available in ROS-2 now. I will say that there does seem to be some rare, but it does happen crashing right now. There's some of the latest updates in the Tesseract Qt backend I think might be contributing to this. We're still working through that, but I've been using it pretty reliably without too much issue. So
Excellent.
Yep, that's all I got.
Any other questions? Any questions for Tyler on Tesseract and ROS-2 and some of the Qt widgets that have been created for working with Tesseract? All right, Tyler, I guess you nailed it.
Thanks.
So awesome. Yeah, at some point, right, I'll probably pester a lot of the Tesseract contributors that I'm personally plugged in with on probably creating something a little bit more authored that people can reference about kind of the state of and what are some of the latest changes and where they can be found to complement the presentation. So, but thanks, Tyler. If you can just shoot me a couple screenshots or something, that'd be really neat. Adam indicated some feedback that it's been working well for him. So thanks, Adam, for chiming in.
Great to hear.
Awesome.
I'll provide those screenshots.
Thanks, man. Appreciate it. All right, great. Lily, are you online?
I am. Can you hear me all right?
Loud and clear. So Lily Bay Wallace is one of our regular instructors for ROS Industrial Training and has been making a number of contributions to the training exercises and content. So she's going to share a little bit about some of the latest features in ROS Industrial Training. Lily, the floor is yours.
Sweet. So I'm just going to do kind of demonstration-based stuff, and you're going to have to pardon the fact it's going to be Inception real quick. Can everyone see? Can you see my screen, Matt?
Yes, it looks good.
Yes.
Okay, perfect. So for those unfamiliar, we've got all of our industrial training exercises, which are more scan and plan application focused in the beginning sort of fundamentals content, even through the more complex content here available online for free. You could just look up industrial training ROS, and it should be one of the first things that appears in ROS-2. And Tiffany Capillari and Tyler Marr were awesome the past couple months, and they developed our latest advanced training, which is motion planning with Tesseract. If you're curious about our previously existing training, motion planning with Move It, that already exists and is a part of the fundamentals course. And this motion planning with Tesseract is to show a little bit more about the pipeline capabilities of Tesseract. And so on this webpage, we have a walkthrough of the exercise where you slowly but surely add additional pipelines, add additional processing to your planner in order to really streamline and create a better looking trajectory. And all of the instructions on how to download Tesseract and how to set up your dependencies is all included on this webpage. And if you would like, you can reference where all of this comes from. This is available at our ROS Industrial Consortium GitHub page. It's all based on the Scan and Plan workshop. If y'all had a chance to come and say hi last year at Automate, this is what we presented at Automate last year, and you can take a look into the code yourself. There's also the slide deck, and this is going to be the content that's going to be presented in July. So if you would like to see this live and in person and assisted, go ahead and sign up. I think Matt said that it's half full. And we're going to go ahead and we're going to go through this content, review some of the types of why we're going to go ahead and do this sort of pipeline construction. And then we'll go ahead and we'll build a task flow like this, where we're going to be just streamlining and adding additional constraints to a free space motion in order to make it have clean and consistent behavior. And I can go ahead and show you real quick what this is gonna look like for us when you're getting towards the tail end of running through this demonstration. We've got this lovely setup. This is really comparable, again, if you saw us at Automate last year. You saw this HC10 on a table. In this case, we had a number of different arbitrary surfaces on which you could draw something. It had a whiteboard covering to it. And then this system, well, you could select where to erase. We selected in particular for this, just our RViz simulation, the walk shape for you to go ahead and look over. And going through these buttons with a couple of additional UIs to help you select the mesh modifier you want, the parameters of that mesh modifier, your direction generator, particulars of your raster planning, and then the some additional toolpath modifiers like the direction in which it's going to follow your rasters and any sort of smoothing. You can expand these drop downs and take a deeper look into the potential options you have. This will allow you to go through the motions and take a look at actually executing this process motion across the surface. I don't know why it decided to just not do that. But yeah, and also you can, if you need to move something out of if it gets itself stuck and you need to move it out of a singularity, you can go ahead and do that. So yeah, again, thank you so much to Tiffany and Tyler for constructing this awesome new exercise that y'all can take a spin for yourselves. And I'll go ahead and drop the links to our greater Scan and Plan workshop if you just want to take a look into our implementation that you may have seen at Automate, as well as the exercise itself in the chat.
All right, any questions for Tiffany? Or sorry, Lily. Look at that, Lily. I think you just wowed them all with all the cool goodness going down on the training side. So I appreciate it, Lily. Thanks for organizing that, and thanks for sharing what's going on the training front. With that being said, Lily, if you can add the links, that'd be super helpful. I'll make sure they get dropped into what I share here. So with that, it's open forum time. Is there any particular things that people are working on or follow-up discussions they'd like to poke at based on what we shared today? The time is yours. All right. So just a reminder that you know, obviously we have a number of different resources out there. Feel free to obviously post up issues as you see them. I will be taking this recording and making it available on the ROS Industrial YouTube channel. I think one of the other things I wanted to highlight, I didn't really jump all over it, Let me go back real quick. I know we have a few folks from the EU today. Just wanted to highlight that the information is available from ROS Industrial European Union's conference. It'll be in Bordeaux, France in July, the 4th to the 5th. I'm booking my travel, so I look forward to touching bases with our colleagues in the EU and our friends at Fraunhofer IPA. Last year, Michael Rippiger represented our organization over at the EU, and we're always looking for synergies with our EU friends. So looking forward to catching up on that one. We'll be hopefully getting some more content out on the robotic blending soon, so stay tuned for that. Other than that, that's all we had. Again, I'm happy to hang out online. If anyone has anything they want to raise or ask any questions, feel free. Yep, Dennis.
Yeah, thanks. Sorry, I just unmuted myself. Yeah, the question I have, it's about your plugin for FreeCAD. I'm using it a lot when working with geometry mesh for generating meshes and so on. Unfortunately, I also wanted to test it, but since I'm already on 2204 and having new stuff just didn't work out, unfortunately. I didn't find time to test it on the older version. Just wanted to ask, how the test ended up, and do you have any plans for releasing this also for 2204 at some point?
Yes. Great questions on 2204. I have some of the same questions. So discussion, and this is the FreeCAD plugin, right?
Exactly, yeah. I mean, I would be also interested what was people's reaction also to the plugin.
Yeah, so as you know, you must have been part of the beta plan. Thank you, by the way, for participating. So we're obviously collecting the user feedback. Tyler, by chance, are you still online? Have you been involved in that particular project? I know Jeremy and Michael are kind of point.
I have not, so I can't really speak to it much.
Okay, and Michael's out today. So I can collect your questions, and there are plans for 2204 in the formal release. I mean, obviously we plan on continuously updating it as Linux moves along. So that is absolutely the plan. I don't have the schedule at my fingertips, so I would have to follow in and maybe add some notes here when I publish the slide deck. So, but no, we're absolutely moving forward, and looking forward to adding a little bit more on motion plan, kind of editing and previewing and editing as well, in that tool set.
Yeah, what was the license once again of the plugin? I'm just not sure. Are you planning to have it open source or as your internal development?
So I think what we're going to do to keep it supported is that we are going to, since it's kind of more of a graphical tool, is that we're going to probably offer it in like some sort of subscription base and make it like maybe pick one of the GPL. That way we have at least enough revenue to keep it alive, since our target audience is like, say, manufacturing engineers that don't want to do any coding, right? If we could take a look in the future about like partner or a developer type license that allows you to like basically hack on it a little bit more unrestricted, we can take that under advisement. But like our original use case was like people that are manufacturing engineering oriented, that they just really want to be able to mess around with their robot, get their robotic system set up in a way that'll work in a ROS-based system. And so this is sort of addressing that feedback, and they were okay and comfortable with some nominal fee. And we're just going to try to cover the maintenance cost. So we're trying to come up with something that's palatable, but like can keep it alive. Since ideally our goal is to make it download and go. Obviously, as you've heard, we've struggled with some of our other open source repositories, you know, with the big push on Tesseract ROS-2, just now getting it really working well in ROS-2. We'd like to stay with this particular tool, like to keep it moving more like in sync with releases and updates.
Mm-hmm. No, that's all fine. I understand this fully. No, cool. Yeah, cool. I mean, we would be at least. I can also imagine that we also buy at least a license for testing on our side, since as I said, we are using it a lot, and if you find it useful, that's great. Also to bring it into our clients' projects and so on.
Sure.
More.
We hope people find it useful, and obviously, if you find things that can be improved, that's the point of doing the beta, right? So.
No, of course, yeah, of course. That's of course. Okay, thank you very much.
Yeah, my pleasure. Thanks, Dennis. All right. Any other questions, comments? No, that's really good.